Across the globe, our planet is facing an unprecedented challenge. Intensifying droughts are pushing traditional agriculture to its breaking point. Vast swathes of fertile land are becoming parched and unproductive, threatening food security for billions. As water sources dwindle and climates shift, the need for revolutionary solutions in farming has never been more urgent. But what if we could defy nature, turning barren, sandy landscapes into lush, productive farmlands? This isn't science fiction, it's the reality unfolding in one of the world's driest regions. Our focus today is Israel, a nation that has historically grappled with extreme water scarcity. Over half of its landmass is desert, including the vast Negev. For centuries, growing food here was a relentless struggle against nature's harsh hand. But instead of surrendering to these conditions, Israel transformed its adversity into an opportunity for innovation. They pioneered a blueprint for agricultural resilience that is becoming increasingly vital for arid regions worldwide, proving that with ingenuity, sand can indeed become soil. So, how is this possible? Israel's agricultural miracle isn't a single invention, but a powerful synergy of three groundbreaking technologies. First, we have advanced brackish water desalination, turning unusable water into a vital resource. Second, AI-targeted subsurface drip irrigation, which delivers every drop with pinpoint precision directly to plant roots. And finally, genetic crop engineering, creating resilient plants that thrive in conditions once thought impossible. Together, these pillars are not just growing crops, they are cultivating a new future for global agriculture. Let's start with the most fundamental challenge: water. Israel has virtually no natural freshwater sources, relying on scarce rainfall and shared rivers. Their solution? Turning the vast, salty Mediterranean Sea into a freshwater tap through a process called desalination. Specifically, they use reverse osmosis, which forces seawater through fine membranes, filtering out salt and impurities. This technology, once prohibitively expensive, has become the bedrock of Israel's water security, allowing them to quench the thirst of their cities and, increasingly, their farms. Israel's commitment to desalination is perhaps best exemplified by its network of plants. The crown jewel is Sorek II, located on the Mediterranean coast. This isn't just a large facility, it's one of the world's largest, pushing the boundaries of what's possible in water production. Its sheer scale and advanced technology demonstrate Israel's long-term vision for water independence and its capacity to sustain a growing population and, crucially, a burgeoning agricultural sector even in a desert environment. It's a testament to engineering prowess. The impact of this infrastructure is nothing short of revolutionary. Just a few decades ago, Israel was teetering on the edge of a severe water crisis. Today, through these massive investments in desalination, they have completely transformed their water balance. They now produce so much fresh water that they are no longer just self-sufficient, they're actually a net exporter of water. This remarkable achievement underscores the success of their strategic approach and the potential for other arid nations to overcome similar challenges through technological innovation and bold infrastructure projects. What's truly remarkable is how the cost of desalination has plummeted over the years, making it an increasingly viable option. 20 years ago, producing a cubic meter of desalinated water cost around 60 cents. Through continuous innovation, improved efficiency, and economies of scale, that cost has dropped significantly. This reduction is critical because it makes desalinated water more accessible and affordable for a wider range of uses, including agricultural irrigation, which traditionally requires large volumes of water. Lower costs enable broader application and greater impact on food production. While desalinated seawater is crucial, Israel also pioneers the use of brackish water, water that's saltier than fresh water but less salty than seawater. This type of water is often found underground in arid regions and is typically unsuitable for direct agricultural use due to its salinity. However, by combining advanced irrigation techniques with genetically engineered crops, Israeli farmers can effectively utilize this abundant, yet challenging, water source. It represents an enormous untapped potential for agriculture, significantly expanding the available water for food production without solely relying on expensive desalination plants. The story of precise water delivery begins in the 1960s with Israeli engineer Simcha Blas, who observed a tree thriving next to a leaky faucet. This simple observation led to the invention of drip irrigation. Instead of flooding fields or spraying water indiscriminately, drip irrigation delivers small, precise amounts of water directly to the plant's root zone, minimizing waste. This innovation, championed by companies like Netafim, transformed agriculture globally and set the stage for even more advanced water management, allowing farmers to grow more with significantly less water. Building on this foundation, Israel advanced to subsurface drip irrigation, or SDI. This system takes drip irrigation a step further by burying the drip lines beneath the soil surface. By placing the water directly at the roots, SDI virtually eliminates evaporation, reducing water loss to the sun and wind. It also prevents runoff and minimizes weed growth, as the surface remains dry. This targeted approach is crucial for optimizing the use of every precious drop, especially when dealing with desalinated or brackish water where efficiency is paramount. Here's where the technology truly becomes revolutionary, integrating artificial intelligence, AI, and the Internet of Things, IoT, with SDI. Imagine a farm where thousands of tiny sensors are constantly monitoring soil moisture, salinity levels, nutrient content, and even the plant's own health. This data is fed into sophisticated AI algorithms that analyze everything in real time. The AI then dictates precisely when, how much, and exactly where water and nutrients should be delivered. This creates a hyper-efficient, self-optimizing irrigation system that maximizes crop yield while minimizing water usage. Companies like Saplant and CropX are at the forefront of this revolution. Saplant, for example, uses AI to predict plant stress days in advance, allowing farmers to intervene proactively. CropX's sensor network and AI platform provide granular, zone-specific irrigation recommendations, ensuring no part of a field is over or underwatered. These technologies transform farming from a labor-intensive guessing game into a data-driven, precision science. This means higher yields with fewer resources, directly tackling the global challenge of feeding more people with less land and water. The combination of SDI with AI and IoT isn't just advanced, it's incredibly effective at saving water. Compared to traditional irrigation methods like flood irrigation or even overhead sprinklers, these smart subsurface systems offer dramatic reductions in water consumption. Delivering water directly to the root zone, only when and where it's needed, prevents wastage from evaporation, runoff, and overspray. This efficiency is a game changer, especially for using desalinated or brackish water, making it economically feasible to cultivate crops in arid conditions. Even with optimal water delivery, crops need to tolerate the inherent challenges of arid environments and saline water. This is where genetic crop engineering comes into play. Researchers, particularly at the Hebrew University of Jerusalem's Faculty of Agriculture, are at the forefront of breeding and engineering crops that can not only survive but thrive in marginal lands. They focus on developing varieties resistant to salinity, drought, and extreme temperatures, transforming the biological limits of what can be grown in the desert. The list of crops being genetically engineered for resilience is growing. Think about staples like tomatoes and wheat, or high-value crops like peppers, olives, dates, pomegranates, and melons. Traditional breeding takes generations, but modern genetic tools like CRISPR-Cas9 accelerate this process dramatically. Scientists can precisely edit genes, introducing traits that allow plants to better manage salt uptake, efficiently use water, and withstand heat stress. This means less fertile soil and brackish water become viable growing mediums, unlocking vast new agricultural potential. A fantastic example of this success is the salt-tolerant tomato. By carefully selecting and engineering specific varieties, Israeli agriculture has managed to irrigate tomatoes with water containing significant salinity. The surprising benefit? These tomatoes don't just survive, they often develop a higher sugar content, leading to a richer, more flavorful product. This demonstrates how genetic engineering, combined with precise irrigation, can not only make farming possible in arid conditions but can also enhance the quality and profitability of the produce itself. It's a win-win for farmers and consumers alike. The most visible evidence of these combined technologies is the transformation of the Negev Desert. Once a vast expanse of barren sand, parts of the Negev are now home to thriving agricultural fields, producing a wide range of crops for both domestic consumption and export. This isn't just about survival, it's about creating highly profitable, lush green farmlands where none existed before. The Negev serves as a living laboratory, demonstrating that the seemingly impossible task of growing abundant food in harsh desert conditions is not only feasible but economically viable. This agricultural revolution hasn't happened in a vacuum. Israel's vibrant, startup nation culture extends deeply into agri-food technology. The country boasts over 400 startups dedicated to solving global food and water challenges, attracting significant international investment. This robust ecosystem of innovation, research, and capital fuels continuous breakthroughs, ensuring that Israel remains at the cutting edge of sustainable farming. It's a testament to how a national focus on problem-solving can create both environmental sustainability and economic prosperity. Let's compare the traditional approach to farming in arid regions with Israel's innovative model. Traditional farming struggles with high water wastage, relies heavily on natural rainfall, and is limited by poor soil quality, often leading to low yields and eventual land degradation. In contrast, Israel's approach minimizes water waste through precise delivery, utilizes abundant brackish and desalinated water sources, and cultivates resilient crops through genetic engineering. The result is high yields, sustainable practices, and the transformation of previously unusable land into productive farmland. It's a stark difference in outcomes. The implications of Israel's success extend far beyond its borders. As global droughts worsen, the blueprint developed in the Negev offers a vital solution for other arid regions around the world. From the Middle East and Africa to the U.S. Southwest and Australia, the combination of advanced desalination, AI-driven irrigation, and resilient crop genetics provides a scalable model for food security. Israel is actively sharing its knowledge and technology, fostering international collaborations to help other nations overcome their own water and agricultural challenges. It's a message of hope in a drying world. What Israel has achieved in turning sand into highly profitable, lush green farmlands is a testament to human ingenuity and perseverance. By combining desalinated and brackish water, intelligently targeted subsurface drip irrigation, and genetically engineered crops, they've not just overcome a geographical disadvantage, they've created a model for sustainable agriculture that can thrive anywhere. This isn't merely about technological advancements, it's about reshaping our relationship with water, land, and food, offering a powerful vision for a future where global food security is within reach, even as our planet faces unprecedented environmental challenges.